So in this short video, we're going to try and look at all things vectors you need to know for GCSE. So a vector is really a movement in a certain direction, certain magnitude or distance. So we could call this the vector A. Okay, so from the north line, turn to a certain angle and I've moved a certain distance. Get this camera to calm down. So any other vector, vectors aren't tied, they can be free. So if I move exactly the same angle, exactly the same distance, and that's also vector A. If I am longer, but say some multiple A, but still in the direction A, or vector A, so a multiple of vector A is just simply a movement in the same direction, which is either longer when K is larger than 1, or smaller when K is less than 1. So K greater than 1. Ka, K less than 1. So that's your vectors there, go in a certain direction, okay, and they are free to move from any point on the page. The vectors are identical if the term from the north line is the same and the distance from the start to the finish is the same. Now we can have vectors expressed as two vectors. I'll show you what I mean by that. So we might go like that to begin with, we'll call that vector A, and then we might go like that. Another vector B. So we've got two vectors put together. We call that A plus B. Now the resultant vector is the movement from A to the end there. So we might put that there and put some letters like that. So A plus B equals O to A plus A to B, which is exactly the same as the movement from O to B. Okay, so this is the resultant vector from the movement of A followed by the movement of B. Now a parallel vector to that could be 2A plus 2B. We've got 2A plus 2B, and so there is our resultant vector. Okay, so if we compare them, and this is the same, this is 2A plus 2B. But you'll notice with algebra, so this one's A plus B, the second one was 2A plus 2B. If I take the 2 out as a common factor, then I can see that it might happen in the same direction, A plus B, but twice as far. So we've looked at free vectors and we've looked at vectors. What we're showing, this property here, shows that the two vectors are in fact parallel. Because any vectors that go in the same direction therefore must be parallel. So a way to show that vectors are parallel is to work out one. So for example, we've worked out that OA is A plus B. Look at another movement, and as long as you can show, so say your first vector is A plus B, any vector that's k lots of A plus B will be parallel. So you're often asked to prove whether two movements are parallel, and you really do that by factorising. You work out the vector movements, and then you factorise and you show that one vector is simply a multiple of the other vector to prove that they're parallel. Now, you sometimes get asked whether vectors are collinear. So that's often not understood, so I'll explain it to you now. So if two vectors are collinear, I'll show a case here. So you've got A, B and C. So A to B and B to C, are they collinear? Now in the diagram I've drawn, they obviously don't look collinear. But what you need to realise is that if you're looking for collinear, then you have a common point. And here's a diagram of two vectors that are collinear. So AB and BC in this diagram are on the same straight line. So what you have here, it's like the parallel lines. You'll find that AB is some multiple of BC, but because you have the common point, that additional piece of information tells you that AB and BC are collinear. So that will help you in proving results. The final thing I want to look at is midpoints and ratios to do with vectors. So if we take a triangle here, I'll call it A, B, C. I'll put A there and B there, say. I might be asked to find a M, where M is the midpoint. And quickly, the midpoint of AC. So start off by finding AC. So AC equals AB plus BC. So that's easy enough. That's equals A plus B. Now we want M is the midpoint of AC, so AM equals a half of AC. So that would be a half of A plus B. So A to M then, moving from there to there, is exactly half of, by definition, A plus B. Now, you might not get given it always as the midpoint. So I'll show you another example. You might be told something like this. So look at this. You might be told that M can have A, M, let's have say B and C, and we're told that AM to MB is in the way we'll put say A there and B there in this example. So AM to MB is in the ratio 1 to 3. So find the vector let's have a look, let's say C to M in terms of A and B. So how do we do this? Well, we know that C to M is going to equal C to A plus A to M. C to A is quite easy, that's A. Now A to M, well that's 1 to 3, you're given that there, so that's going to be 1/4 of the way, so think of the full distance as 4, and you come one part of that 4 down, so it's going to be 1/4 of the way of A to B. Okay, now A to B, let's work that out. So going from A to B is going to be, let's keep that A there, because remember we're going from C to M, A plus 1/4 of. Now from A to B is against the vector A, so minus A plus B, minus A plus B. And some final tidying up here, so we can express this as simply as possible. That's A minus A over 4 plus B over 4. Now A as a whole, and take away 1/4 will leave me 3/4 of A plus 1/4 of B. And I have 1/4 as a common factor, and we've seen before to prove that vectors are parallel or collinear and need to find common factors. And I'm left with 1/4 of 3A plus B. So really I've taken you through most of the things that you need to know here on vectors. It's a quick reminder video, only 8 minutes long. That covers virtually everything you're going to need to know to get you through GCSE questions. So I hope it helps.